So we're working on an idea with transforming exponential functions. And here's a tough thinking question. They've told you that some function, and it's an exponential function, they've told us that, when we take it and vertically stretch it by a factor of 36, right? I think you guys used A for that idea. It's actually the equivalent of AK, what did you use here? C? Is that what you used in here?
Yes.
Yeah. It's the equivalent of adding the value of 2 to the exponent. Now, because this function is an exponent, that's very important. We have to know that we are working with a to some x. We do know that that's what this function is. We just don't know essentially what our a value is. Now, the one that gives us the hint is this idea of 36. So we write out an exponential function with this idea. So let's say we write, well, we know f at x, okay, is equal to a to the power of x. Okay, so let's compare two of them. Instead of writing f at x is equal to something, we're going to write, we're going to replace our f at x with our value a here. Okay, and we know apparently that a times this 36 is the equivalent of ax plus 2. Okay, apparently these are equivalent. Our a is essentially what we're trying to find out here. Now, what we're going to do here is, because this is multiplication, we have to actually be relatively strong with our exponential law rules. This can be broken up. This can be broken up into two exponential functions multiplied by each other. So in other words, I can rewrite it on the right side as both of them to be base a, and one of them to be to the exponent of x, the other one to be to the exponent of 2. Okay, and sorry, I wrote that wrong. There should be an a at x there. Well, since that 36, and that's to the a at x, algebraically what we can do is we can eliminate our a at x. If we divide, because it's an equation, if we divide both sides by a at x, it will help us eliminate that from both sides. So on the one side, we'll be left with just 36 is equal to the value of a squared. Okay? And because a squared, to separate for a, we just use the square root. The square root of 36 gives us a value of 6 for a. So the exponential function that keeps this true, our function, f at x, must be 6 to the power of x. Okay? And it makes sense when we'll even try to do a little graph. So in other words, 36 times 6 to the power of x is the equivalent of 6 to the power of x plus 2. Those two are the exact same thing. And I think I did it with a graph. Yeah, I did. I'll get rid of these guys because they're not important. But if you notice, take away our lines, our original 6 at x is written like this. And when I stretch it by 36, it makes our orange line. And then when I put our 6x plus 2, it superimposes blue right over the orange. So they are identical functions. And that's essentially the idea to solve it.